Hi everyone, welcome back. Let's write some more Leetcode today. Today we are solving maximum number of points from grid queries. So the problem states that basically we will be given a grid and then we will also be given an array called queries, and for each query we will start at the top left of the grid and we can continuously look up, down, left, and right as long as the elements to the up, down, left, and right are less than the current query. And after we have looked all the way through as much as possible, we return the number of elements that are less than or equal to the current query in our resulting array. So if we look at this example, for 5, if we start at the top left, there are 5 elements that can be reached. And if the number is 6 and we start at the top left, there are 8 elements that are able to be reached. And if the element is 2, we start at the top left, 2 is equal to 2 is equal to, so we cannot look to the right or down anymore. And there's nothing to the left or the right, so we stop there. And there's only one element that matches that, so we return 1. And our resulting array would be 5, 8, and 1. So now that we have seen some examples, let's get to how we can solve this problem. So one way that we can solve this problem is we can use a min heap. So what we'll do is first is we will set up a queue array that is sorted. So it will contain the queries and the index that matches it. And we will also have a visit array to keep track of all the cells that are visited, so we don't have to do any repeated work. And we will also have a min heap array where the first element is the weight, the second element is the row, and the third element is the column. And we will always start at the top left, so it will be 0, 0, initialized in a min heap. And the first element will be whatever value is on the top left, and the score will be used to keep track of the number of valid values, and we will update it to the resulting array when it's time, and the resulting array will be initialized with 0 times the length of the queries. So what we will do is we will go through each queries and we will start at the top left, and whenever this query is no longer valid, we will continue searching rather than restarting, since whatever can be contained in this query will be able to fit into the larger query, so we can just continue from there. Once we have find the result of the first query, just update the result to the resulting array and then look through the next one, and then we will continue doing that until we have finished all the queries. So let's go over this example real quick. So we're first on the first query, and by the way, I will use green as what we have visited, and I will use blue as what has been officially added to the score. So we first visit the node at the top left. So we realize that 1 is a valid value, so we can update the score and look to the right and down. And we realize that both of these are equal to 2. So query 2 has officially ended. So we will add it to result. It's an index 2. So we put in index 2, update 1. So now we can look at the query 5, and we will first look at this value because it's the first value in min heap. And we realize that 2 is valid, so we will look to the right and down. And now we look at this value because it's the next smallest one, and realize that 2 is valid again, so we can look to the right and down again and update the score. And as we keep looking, 3 is also valid, so we can look down and update score. And then the next smallest element, 3, is also valid, so we will look to the right and update the score. And we realize that the rest of the values are not valid, so we can update the result on 5. It's an index 0, so we update it here. And now we can look at query 6. So in query 6, we realize that 5 is valid, so we would mark that one, and we can look to the right and down, but these have already been visited, so we would just pop this from the heap and continue searching. And the next smallest element, 5, we realize that it's valid, so we would update the score and look to the right. And the next smallest element, we realize 1 is also valid, so we will update it and continue searching even though all the nodes around the surroundings have already been visited. So we will just pop from 1 and update the score and continue. And now 7, the next smallest element, is not valid, so we can just update the score at 8. And now we have found the result and we can return it since we have done all the queries. So the time complexity would be O of k log k plus nm log nm. So k would be the number of queries and we'll have to sort it, so that's why it'll take k log k times. And nm log nm would be the number of rows and columns, and it would take that much time because of the min heap. It would take about nm log nm time, worst case, to go through it all. And the space complexity would be O of nm, where n is the number of rows and m is the number of columns, because that may be how large our visit set could be. So now let's get to the coding part. So first we'll set up rows to the length of grid and columns to the length of grid 0. So that will be the length of columns. And we will make our queue array. So it will be ni for index and number and enumerate queries. So we'll call it in, and then we will sort it. So queue.sort. And we will initialize the min heap to a tuple with grid of 0, 0 in it and 0, 0, because that's the top left. And visit set will be set to a set of 0, 0 in it, because that's the only one that's visited in the beginning, the top left. And initialize the score to 0. And we will initialize the resulting array to 0 times the length of queries. So now we can look through the Q array. So for limit and index in Q, while the min heap is still there and the min heap of the first element is less than the limit, then we can pop around the min heap. So value of rows and columns will be equal to the heap pop of min heap. As soon as we pop, we can update the score. And I will set up this directions array just to make it easier to write the for loop later. It's basically the directions we can go. So it would be up, down, right, or left. So row +1, row -1, column +1, and column -1. Okay, so now we will call for dr, dc in directions. So we're looking through the directions, and we gotta make sure that the numbers are within the range of rows and within the range of the length of columns. So let's see. And we've got to make sure that it is not a cell that we have visited before. So dr, dc not in visit. And if that's the case, then we can push to the min heap and add that element to the min heap. So grid dr, dc, dr for row and dc for the new column. And then we will also want to add it to visit so we don't have any repeats. See? And in the end, we can update the resulting index to equal to the score, and then we can return result. See if it works. Okay, perfect. Hope this was helpful. Thank you all for watching. If you have any other questions or comments, feel free to leave it down in the comment section, and I hope to see you all again soon.